right, we talked about congruent triangles yesterday. So basically we said this. Let's get a different triangle than what I used. Why does it always do that? I don't know why it makes that kind of a... Oh, there we go. Just click off on it. Alright, there we go. Let's just take an obtuse triangle. For some reason, I don't use obtuse triangles much, but I'll use it this time. So let's say we had a triangle right here. Copy and paste and put another triangle right here. And what do we know so far? In order to say that they're congruent triangles, A, B, C, let's label a little different, D, E, F, like this. Okay? Watch. So far, this is what we've learned. In order to have congruent triangles, you must have all the corresponding parts being equal to each other. Agreed? All right, so that angle must equal that one, and this one must equal, and this one must equal each other. But is that enough to say that they're congruent triangles? No, they're not. Let me just show you why. Because if I did this, I'm going to hold the shift key down. What it does, it keeps the same proportion, okay? So it doesn't change the shape of it. All I'm doing is changing the what? The size of it. Now look at the angles, though. This angle and this angle, they're still the same measurement, okay? I didn't change the measure of the angle at all. But are they congruent triangles now? No. So just because the three angles, listen, just because these three angles equal these three angles does not mean that your triangles are congruent to each other. Does that make sense? All right. But what if we did this? What if we said that side is equal to that one, this one's equal to this one, and this one is equal to this one? So there's 6 things, right? We have 3 angles that we showed, 3 pairs of angles that we showed equal to each other, and 3 pairs of sides that we showed equal to each other. So if we have all that stuff right here, if I know that A is equal to E, B is equal to D, C is equal to F, and so on. If I know that stuff is true, what can I say about these 2 triangles? They are what? Congruent. And if I wanted to, again, this is all review, if I wanted to call this triangle, let's call this triangle ABC. And I could say that with this information that's given right here, I could say that triangle ABC is congruent to what triangle over here? EDF. Good, because look what I did. ABC goes from 2 arcs to 1 to 3. Everybody see that? So 2, 1, and 3. So what do we have to do over here? 2, 1, 3. So that would be triangle EDF. We okay with that? I didn't have to call it ABC, did I? I could have called it, let's give one other option. What's another option? CBA? CBA is too easy because it's just backwards of that. Let's mix it up a little bit better than that. BCA? All right. So BCA. So if I call this triangle BCA goes from 1 to 3 to 2, what would I have to call this one? DFE. Everybody see that? But what did we know so far? We knew all 3 angles were equal, and we knew all 3 corresponding sides were equal. Does that make sense? All right, so if I know that all 3 sides are equal to all 3 sides, and all 3 angles over here are equal to all 3 angles, then I know these triangles are congruent. But this lesson that we're going to do today, you don't have to know that much stuff. And that's what's kind of cool about this. Let me just show you. Let me grab another triangle. I'll grab that triangle right there. Okay. So watch this lesson. Make it just a little bit bigger. And we'll make these nice and easy. I'll just copy and paste, put them right next to each other. I won't twist them or flip them or anything like that, just to make it super easy for us. All right. And let's just use different letters. I'm tired of ABC. So let's go PQR. Let's go XYZ. All right, sounds good. XYZ. All right, so I've got 2 triangles right there. Now, do I know those triangles are congruent?
No, not yet.
No, I have no idea because I don't know anything about the angles. I know nothing about the sides. I can't say that they're congruent. But watch this. If I was to do this, if I was to say that this side is equal to this side, all right, this one right here was equal to this one, and this one was equal to this one. Now, I didn't tell you anything about the angles whatsoever. All right, all I said was this side, these 2 sides are equal, these 2, and these 2 right here. And that's all I told you. I didn't say anything about the angles. That's enough right there to say that these 2 triangles are congruent to each other. All I have to know are the 3 sides. Now, we're not going to do it because it's just kind of time restrictive. But if I had like little sticks or something, or Alex mentioned in her math class or other school, would they use like spaghetti, like the dry spaghetti things, and you broke them into pieces? Alex, am I right on that? Right? Yeah, okay. So you know, you could take little sticks or little lengths, and you could have like this a certain length and this one the exact same length. So two things, you know, the exact same length. This are two different lengths. These are two different lengths. And then you make a triangle out of these three. You make another triangle out of this. There's no way that you can make a triangle that looks different than this. The only way that you can make a triangle will be exactly like this. Now, it may be twisted a little bit or something like that. You know, you could twist it around, but the sides are all the same. Those angles are going to be the same as well. So that's enough. I don't have to do all 6 things. All I got to do are 3 of them. All I got to do is show that these 3 sides equal these 3 sides. That's enough to show that these triangles are congruent. And we give a name for that. We call this side, side, side. It's a theorem. I'm pretty sure they make it a theorem. Nope, I lied. It's a postulate. It's a postulate. I thought it might be. All right, so this is a postulate that says if all 3 sides of one triangle equal all 3 sides of another triangle, right, then those triangles are going to be congruent to each other. That's a postulate. Remember, a postulate is just an accepted fact. You don't have to prove it. It's just accepted, right? So there's no proof for this, but you can say that they are congruent. Now, instead of writing the word side and then side and then side, right, you can make it a little easier. And you can just put 3. That's an ugly looking S. I don't know if I can make it any better or not. So that's a little bit better. Anyway, so I can just write it. Shh, listen. I could just write it side, side, side like this. Now, we don't say SSS. So if I said, give me a reason why these 2 triangles are congruent to each other, you would say what? Side, side, side. So I'll put that in quotes. This is how you would say it. You would say side, side, side. But when you write it, you don't have to write out the word side. You can just write SSS, okay? But you're not going to say SSS. We say side, side, side. Everybody got that? All right. So that's a nice thing right there. That's nice to know that if you have two triangles and these 3 sides are equal to these 3 sides, then they are congruent. So guess what? If they're congruent now I can say that triangle, what do you want to call this? PQR? All right. So if I call this PQR, it's going to be congruent to what? It's got to be XYZ. Everybody see that? Because they're the ones that match up. So they are congruent to each other. Now, I didn't say anything about the angles to begin with, did I? But now that I know that they're congruent to each other, what do you think I can say now about angle P and angle X? That they are equal. That's right. They are congruent to each other. Do you see that? And what about Q and Y? They must be what? They must be equal to each other or congruent, right? What about R and Z? They must be equal to each other. Now, I didn't say they were equal to each other from the beginning, did I? But now that we said that all 3 sides are equal to all 3 sides and the triangles are congruent, now I can say, look, P and X are equal. Q and Y, R and Z are equal to each other. Okay? And let me give you a reason for that. This is really important because you're going to be using this. This is the first time you've heard it. It's the first of many, many, many times we're going to discuss it. Okay? So, Y is angle P equal angle X. And you could list the other ones too. Q equals Y, R equals Z if you wanted to. So we need to give a reason for this. All right, I want a reason why angle P is equal to angle X, because we've already shown that we have congruent triangles, didn't we? And what are these 2 angles? What is P and X? They're corresponding angles, or they're corresponding parts. Remember we talked about that yesterday? There's 2 parts to the triangle. There's the angles and the sides. So these are corresponding parts. These corresponding parts are parts of congruent triangles now, aren't they? So what must be true about the corresponding parts of the congruent triangles? They must be what? They must be equal, right? Or the book likes to say congruent. We'll say congruent, okay? So here's what I'm going to write down. I'll even put it in a different color. Make it stand out a little bit. Okay, so watch what I'm going to write. Write this down. You should write it down. So why are those 2? Because corresponding, and I'll show you a shorter way to write this, but let's write the whole thing out right now. Corresponding parts of congruent triangles. I'll just put the symbol for triangles. Is that all right? All right, corresponding parts of congruent triangles are congruent. Again, I want you to understand what this means, because I'm going to show you a little shortcut on how to write this, okay? But I want you to understand what it means. Corresponding parts That means the parts that match up, either the angles or the sides, right? So these two angles are corresponding parts. Those corresponding parts are parts of what? Congruent triangles, right? Because these triangles, I said, are congruent. So these corresponding parts are of congruent triangles. What must be true about those corresponding parts? They must be what? Equal, or we say congruent. Let's stick with congruent. That's what they do in the book, okay? What about Q and Y? Why must Q and Y be equal to each other then? Because they're what? Because they are what? Corresponding parts of congruent triangles. And they got to be equal then, right? They got to be congruent. Everybody with me? Look at R and Z. What are they? They're corresponding parts, right? They're corresponding parts of what? Come on. It's right there in front of you. It's in blue. They're corresponding parts of what? Congruent triangles, right. They're corresponding parts of congruent triangles, and they must be what then? They must be congruent. Okay? Does that make sense? So if I know my triangles are congruent, that means all the angles that match up with each other must equal each other, right? That's basically what it's saying. But I have to have congruent triangles for that to be true. Here's a little short way to write this. We write it like this. Corresponding parts of congruent triangles are congruent. And that's a nice shortcut, isn't it? I used to teach out of another book that said equal at the end. We used to say CPCTE. And then this book says C for congruent. But it's kind of the same thing, though, isn't it? All right. What's that? Well, you don't put it in there. You just put the important words in here. So watch. Again, what does this mean? This means corresponding parts of congruent triangles are what? Congruent. You see that? So that's very, very important. We're going to use that a lot a little bit later on. All right? So make sure you understand what that means. I think I'm going to teach this kind of like in 2 days. I want to go over the basic stuff, and then we're going to get a little bit more complicated tomorrow with this, okay? Let me see what else. Where did they put the second one? Do you see side angle? Oh, there it is. It's hiding. It's bottom of 264. There it is. Okay. So let's do this. Let me grab another triangle real quick here. We'll grab the obtuse one. Alright, make it just a little bit bigger. And then, there it is right there. Oops. Alright, let's label this. What do we want to label this? Here's my initials, Ash. A-S-H. Somebody give me your initials. It doesn't have an A, S, or H in it. What is it? I got an A already. Oh, E. E what? M. B. Alright, there we go. Okay, here we go. So we've got two triangles right here. Now watch this. Everybody watching? We've got a few minutes here, so let's pay attention. What if I give you this side is equal to this side? Is that enough to say these triangles are congruent? No way. All right, because this could be different length. You know, just one side's not enough. What about this right here? Is that enough to say that they're congruent? No, because look, this could be angled all kinds of different ways, couldn't it? Still be the same length, but it could be angled out here, it could be angled here. Does that make sense? And it wouldn't be the same triangle. But here's another thing they tell us. They tell us that this angle right here is equal to this angle right there. Now let's think about this. If I gave this length is equal to this one, and this one's equal to this one, and I said the angle between those two sides have to be the same, then I can't take this angle and move it this way or move it this way, can I? Because then the angles wouldn't be equal to each other. So watch. Again, instead of saying all 6 things, all I got to do is say 3 of them. I've got 2 sides and an included angle. Do you hear that word I used? An included angle. What does that mean, do you think? It's the angle that does what? Includes. Well, that's between those 2 sides, right? Do you see it? It's the angle between those 2 sides. So we call this, what do you think? Side, angle, side. All right? So we call it side, angle, side, and we shorthand it. It should be easy. What is it? SAS. SAS, okay? But we don't say SAS. What do we say when we verbally say it. We say side angle side. If you write it down, you can just put SAS for side angle side. All right? So that's another one. You don't have to know that these two sides right here are equal. You don't even have to know anything about the other two angles. If this is all you know, if you have two sides and an included angle, everybody hear that? It's the angle that's between those two sides right there. If you have two sides and the angle between those two sides equal to the same thing over here, two sides and an angle in between them, then they are congruent. So what about this? Now we've established that they're congruent, right? So let's write that down. Triangle ASH would be congruent to triangle what? EMB. What can I say then about angle S and about angle M? What can I say about angle S and angle M? They're congruent. Why? Because of what? CPCTC. Nope, no homework. I'll give you homework tomorrow.
Please come to the office. Samir Bradley.